Hello and welcome back. And in this lecture, we are going to see the imputation methods to handle the missing values. So under the imputation methods, we are going to discuss today about the mean, median, and mode imputations. So we will have a small introduction to this, and after this, we will see that how the mean, median, and mode they are used for handling the missing values. Okay, so before we start, we should understand what is the mean, what is median, and what is mode. So you have to consider this data, which is score basically for a exam score. So it's 65, 72, 81, 90, 65, 72, and 85. So mean means you have to find out the average. Average means sum of all of these divided by how many numbers are these actually. So these are 1, 2, 3, 4, 5, 6, 7. So you will divide it by 7 basically, right? So it will come like 75.71. So this is the mean. So this is how the mean is calculated. Now let us come to the median, right? So this is high school maths only, nothing else. So in case of median, you just have to arrange all these values in the, in sorted manner from any order, right? Like, ascending or descending any order, right? And then you have to find out the middle value. So the middle value here is 1, 2, 3, 4, fifth one. So this is the 72. Okay. So 72. So in a sorted range of values, sorted value set of values, whatever comes in the middle, that is known as the median. So here the median is 72. Now comes the mode. So in case of mode, what you have to do, you have to count the number of times the values have occurred. Like 62, 65, how many times it occurred? It occurred twice. 72 occurred twice. And each of the others, they have occurred only once, right? So if you see, the frequency of 65 is 2, right? So 72 is 2. So what is the highest frequency for any of the element in this set of values? So this is for two values. One is for 65 and the other one is for 72. So in this way, the most frequent values are 65 and 72, and both have same frequencies. Since both have same frequencies, so both are the mode of this data set. So it is having bimodal, right? This is bimodal data, right? So 65 and 72 both are having the same frequency and they are both the highest frequency. So that is why it is a bimodal data set. Okay, so now there are a few points which you must need to understand that mean is very much sensitive to the outliers. We will understand what is outlier. So basically, in a set of values, if you find something which is either very high or very low compared to the other values in the data set, then in that case, those values are known as the outliers, right? Which doesn't fit into the range, into which the usual values in the entire data set have been placed, right? So in that case, those values becomes outliers. When we talk about the median, then median is more robust to outliers, which means when you talk about when you have to handle the outliers, then in that case you should use the median. And mode is basically useful for the categorical data. And this categorical data we are going to discuss in the coming videos. Okay, so now we have understood like what is mean, median, and mode. Now we are going to understand the distributions, the different kind of distributions. Distribution means how the data has been spread across. Okay, so the first one is the normal distribution. So this normal distribution is known as the bell curve distribution or the Gaussian distribution. Okay, it is a kind of probability distribution that describes how data points are spread out, right? So in case of normal distribution, when you plot the data in a normal distribution, then your plotted graph looks like a bell, right? You can see that it is a kind of bell which is looking like a bell. So that's why it is known as the bell curve, right? Or the Gaussian distribution as well. So what happens that in Gaussian distribution or the normal distribution, what happens that all the values around a central point, they are equidistant from this point, and also they are equidistant from each other as well. Okay, so the maximum value is at the equidistance here as well and on the left hand side as well. Okay, and minus 2 here and plus 2 here, both are equidistant from 2. So this kind of distribution, this kind of data distribution, where the mean is 0, right? Mean means the point or the, where the, you know, things around which the things are revolving around, all the data is revolving around, that particular point is is having the value zero, then in that case, such kind of distribution is known as the normal distribution. So why it is zero? Because you have the data like -3, -2, -1, 0, 1, 2, 3. Now add all these three, all these values, -3, plus -2, plus -1, plus all these. Then you will get zero, right? So if you divide zero by, 6 and 7 values, it will be zero, right? So in case of normal distribution, mean is zero and standard deviation is 1, right? So in case of normal distribution, the data is arranged in such a manner that the standard deviation, which means standard deviation means the difference between the one value to the other value. Like between 1 and 2, the difference is 1. Between 2 and 3, the difference is 1, right? So this is called the standard deviation where this is the standard deviation, and this is called the normal distribution where the uh, standard deviation is 1 and the mean is 0. So always remember this, and this is asked many times, like what is a normal distribution and what are the characteristics of it. Okay, so in case of normal distribution, the standard deviation is 1 and the mean is always 0. Now comes to the key characteristics of the normal distribution. So it's symmetric. So you can see that it is very much symmetric, like on the around the z value 0, the data points have been spread equally and evenly, right? And it's a bell shaped. So most data points cluster around the mean, tapering off gradually towards the extreme. So it looks like a bell, right? That's why it is also known as the bell curve. Then comes the mean. Okay, so in mean, median, and mode, all these values are equal for the normal distribution. So if you find out the mean, if you find out the median and the mode, right? So all these values will come equal to each other, right? So here the example has been given, which is something different than this one, right? So this is 60, 62, 65, 67, 68, 69, and all these values. So this has been just the representation. So this is the characteristic of the of the normal distribution, that whenever you will find out the mean, median, or the mode, then in that case, the values, all these values like mean, median, and mode, all these will come as equal values. Like here, the mean will come as 70, median is 70, and the mode is also 70. And standard deviation is 5. So most of the values are, having the difference of 5. So most of the data, around 68%, and that has one standard deviation, right? So standard deviation is 5, and mean, median, and mode, they have equal values. Okay. And what are the real world applications, like in the finances, stock prices and the returns, medicines, blood pressure and cholesterol levels, if you are trying to find it out, social sciences, IQ scores and survey responses. These are the places where the normal distribution is used. Now, the second term that we must need to understand is the outliers. This is very simple to understand. Outliers are the data points that are significantly different from the other data points in a data set. They are values that are unusually high or low compared to the rest of the data, right? So here you can see these are the data set of the exam scores from a class of 20 students. So all these 20 students have these kind of data, and you can find out that there is one student whose data is 150, whose marks are 150, right? So if you have to identify the outlier, then you can see that in this data set, the value 150 stands out as an outlier. It is significantly higher than the rest of the score. So you can see either most of the values are around between 65 to 99, but there is only one value, which is 150, which is too high compared to these values within the range of 65 to 100. This is far away from that range. So that is why this value is an outlier, right? So why it is an outlier? Because 150 is far away from the mean, which is around 85 here, and the median in the data set, right? So you find out the mean and median, and then, for the machine, you can see that, yes, you can easily find that 150 is the value, which is outlier. But when you will be programming it, when your program will be able to identify it, then in that case, it should have to do some calculation. So that calculation will be the mean and the median. So if the value is very far away from the mean and the median, then in that case, we say that, yes, this is an outlier. And now the second thing is how you will identify an outlier is the frequency. So no other score is even close to 150, which means that there is no other value which is approaching towards 150 or equally equal to 150. So the frequency is only one for this. And the context is that in the exam format and content, a score of 150 is very much unlikely. Now we have the type of outliers. So one is point outliers, single data points that are significantly different. Like here in the example, it's 150. So these are the point outliers. Then we comes like contextual outliers. So data points are unusual given the context. So we are talking in terms of the context. Like this is the exam. So if we talk about the context, then this is the exam context. And in the exam context, the values are not unusual, right? The values are very much unusual if it is 150, right? Right. So these are the outliers who are very much far away in terms of point outliers and in terms of context as well. And what is the impact of outliers? Right. So outliers can affect mean and standard deviation calculations, and they can skew data distributions, and they can influence statistical models. Okay. So in the next video, we are going to discuss ahead from like how to deal with the outliers. So in this video, this is more than enough that we have discussed. So I want to keep the videos, smaller. So contextual outliers and what are the outliers, how your program can identify it, all these things have been discussed here. So we have seen like how the outliers affect as well. So, the calculations will be not that efficient to train your model properly. So this is how they influence the outliers. So in the next video, we are going to meet again. So till then, have a nice day and bye bye. Thank you.